This video is going to provide a high-level overview of a new technology available at F5. Through its acquisition of MantisNet, F5 now has a cloud-native observability solution to provide to its customers. This solution is called eBPF Observability, or EOB for short. At the highest level, EOB is about getting at data within cloud-native environments in order to establish end-to-end visibility, or observability, if you will. By cloud-native, I simply mean any environment that leverages containers at the core of its architecture. This could be something as simple as a roll-your-own Docker lab implementation, or something as complex as a production environment running on Red Hat OpenShift, for example. The main point is that wherever containers can be hosted, EOB can provide value. Now, if you take a look at the left-hand side of the screen, this diagram gives you a high-level view of how EOB works. It's made up of those red F5 circles. Those are representative of the EOB agents. These agents can be placed anywhere within a cloud-native environment. Specifically for this discussion, we'll focus on 5G SA environments, but please keep in mind that this can provide value in any cloud-native construct. Once those agents are put in place, they can start collecting data within each node. This is all of the pod and container traffic that exists on each node. A best way to think about how this is deployed is that these agents are being deployed as a daemon set. Whether it's via Helm chart or operator, at the end of the day, it's a single point of presence on each node to gain visibility into the pod and container space. This is not a sidecar-based approach where you need to have a sidecar agent or container on every pod that you're looking to monitor. The idea here is to have that single point of presence to reduce the overall footprint and also leverage some of the core competencies of eBPF to be able to do things in a more performant manner, which we'll get into here in just a moment. Once those agents are in place, they will start collecting data and sending it down into the message bus. They absolutely can grab packets, but more importantly, what the agents are doing is they're multifaceted, right? So, packet capture, it's no secret to say it's a very resource-intensive process within cloud-native frameworks. It takes a lot of resource power in order to fully duplicate a network via packet capture. What EOB is trying to do is to take a different approach, to say, yes, packets still matter for RCA, for troubleshooting, for forensics, ad hoc use cases. But what we're trying to do with EOB is to focus on the messaging that's occurring, to be able to get very granular and look at the message in between the different network functions and to pull the payloads out, to pull the headers out associated with this messaging going back and forth to then provide the follow-on analytics and security tools. So yes, packet capture can be fully used and utilized with EOB, but the next point of the conversation is about the data sets we can pull out. So if you look at the message bus where we're publishing data down into, we'll work our way left to right, starting with the control topic. The control topic there in the black rectangle, that is really just a method for controlling the agents. So we'll set that to the side for a moment. If we look at topology metrics, so what can these agents collect from a topology standpoint? So this is understanding everything related to containers, right? What makes up an AMF or SMF? The links, the flows, the processes, the labels and annotations. What is an AMF today? How is that changing over time? That's what makes up some of the topology metrics. Moving to the next box for the flow data, this is looking at more than just an IP-based traditional flow representation of flow data, right? Yes, we include net block information within the flow data, but more importantly, we're rolling up context. These agents are sitting on the endpoints themselves, so we can look at network events and say, all right, this network event was associated with this container. Here's the process ID, the parent process ID, the actual executable that was associated with that particular network event. So it gets a lot more granular and a more full stack view, if you will, from a flow standpoint. We also can pull out protocol data from these environments. So looking at breaking down different protocol stacks. For 5G, that would be the SPI stack as a whole. For non-SPI interfaces, PFCP, eCPRI, looking at F1AP, for example. So taking unstructured traffic, sending it down into the message bus to be fed into security and to analytic tools. Then moving on to plain text payload. So this is how we deal with encrypted traffic within a 5G core control plane, for example. An important thing about how we're leveraging eBPF with these agents is that we're looking at the messaging prior to it becoming packetized and thus encrypted on the send side of a relationship. And then on the receive side of a relationship, we're seeing the plain text payload after the packetization and encryption has been stripped away. So essentially, because we're viewing things from the kernel, we're able to get at the plain text payload in a much more performant way than if you were to take a traditional approach, which is very packet heavy, which is grabbing encrypted traffic, grabbing the keys, sending them to a decryption engine to ultimately get at that plain text payload that we're able to just natively get from our point of presence on the actual node itself. And then back to packet capture once again, full capable packet capture with the solution, but we see it as a tool amongst many. Final 2 points I'd like to make from an introduction standpoint to the solution is really the first one being the demarcation point, right? So this solution is all about solving a tough problem, and that's getting at data within containerized environments. It does not have any analytics built in. And that's by design. The idea here is think of this as a pub subsystem where these agents are collecting all of this data, all these different metrics or key value pairs, the data sets from each individual node it's sitting on, and then publishing it down to the message bus. That message bus is the demarcation point where security tools, analytic tools, service assurance tools can then consume the information from us via establishing a client relationship to the message bus. The final point I'd like to mention is that with EOB, everything we're doing is completely vendor agnostic. And that's because we're leveraging eBPF, because we're sitting at the node level from an agent point of view and building visibility up into the pod and container space. Everything at that pod and container space is an abstracted layer for us. So it doesn't matter if it's Nokia, Ericsson, Samsung, you name the vendor, we can provide a common point of view across all of the different vendors in the way we are collecting data. And then we're presenting it down to the clients via the message bus connection. And that sums it up as a quick overview of EOB and some of the key takeaways for the technology. Thank you.